Hello everyone, welcome to the solution of LeetCode problem 210 named course schedule 2. In this problem, there are total of n courses you have to take. Let's consider num courses will be n. Now, each of the courses are labeled from 0 to n minus 1. Now, you are given an array of prerequisites where prerequisites of I is A of I and B of I. Indicates that you must take courses B of I first if you want to take the course A of I. Now, for example, the pair 0 and 1 indicates that to take the course 0, you have to first take the course 1. That means course 0 is dependent on the completion of the course 1. Now, we have to return the ordering of the courses you should take to finish all of the course. Now, if there are many valid answers, you can return any of them, and it is impossible to finish all of the courses. If it is, we have to return a empty array. Now let's consider the first example. Here, the prerequisites are 1 and 0. That means course 1 is dependent on the course 0. So here, if we finish the course 0 first, then if we finish the course 1 first, after that, it will be one of the valid sequence. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Here, the course 2 is dependent on the course 1. Course 9 is dependent on the course 2 and course 1. Course 7 is dependent on the course 5, 2, and 1. Now here, which algorithm we should use to solve this problem? At first, as there is the dependency, we can solve or we can assume that this is a graph problem. But which graph problem? Now, if any kind of problem, we have to deal with the dependencies, we can basically solve this problem by using the topological sort. And to implement the topological sort, we will use the Kahn's algorithm. Now, similarly, we will use here the Kahn's algorithm. So before jumping into the Kahn's algorithm, we have to understand one thing, which is in degree. And in degree is the number of edges coming towards a node. That means for this node 9, the in degree is 2, because there are 2 edges coming towards 9. So to implement the Kahn's algorithm, we will use the BFS, which is breadth first search. And BFS basically a level by level order search. So by using the BFS, we will implement the Kahn's algorithm. Now, let's dry run the topological sort Kahn's algorithm. So here, we have to first take which node has the in degree of 0. The node 1, 3, and 6 has the in degree of 0. So we can start the BFS from 1, 3, and 6. Now, what is the front element of the queue? It is 1. So we have to remove the outgoing edges from 1, and we have to insert 1 into a visited list. Now, the children of 1, which is 2, has the in degree of 0, and the children of 1, which is 8, has the in degree of 0 now. So we have to insert 2 and 8 here. Now, we have to remove 1, and we have to remove 1. Now our front element of the queue is 3. So we have to remove the edge between 3 and 4. And we have to insert 3 here. And as the 4 has in degree of 0 now, so we have to add 4 here into the queue. Now, we have to remove 3 and remove 3 as well. Now our top element is 6. So we have to insert 6 here, and we have to remove the outgoing edges from 6. So we have to remove 6 here, 6 here, and as none of the edges becomes in degree of 0, so we don't have to add anything into the queue so far. Now our front element of the queue is 2. So we have to exclude 2 from the graph and the queue. Now we have to remove the outgoing edges going out from 2. Now our front element of the queue is 8. So we have to remove 8. And we have to add 2 and 8 also here. Now 8 does not have any of the outgoing edge so far. So we don't have to add anything into the queue till now. Now our top element of the queue is 4. So we have to remove 4 and add 4 into the queue. Now we have to remove the outgoing edge, and the 5 has become in degree of 0. So we have to add 5 here. We have to remove 4. Now for the 5, we have to remove it and insert 5 here. Now for the 5, we have to remove the outgoing edge. So the 9 and 7 will become the in degree 0. Now we can process the node 9. After that, we can process the node 7. Now here we can see that this is one of the valid sequence. That means to finish the course 5, we have to finish the course 1. To finish the course 2, we have to finish the course 3. So this is how basically the level by level BFS or the topological sort works here. Now one condition, in which condition we will not find any of the valid sequence if our graph has the loop. Suppose it is a and it is a node B, and B is connected to A, that means B is dependent to A and A is dependent on B. If in any of the graph has this kind of cycle, that means it is not possible that we have completed our course. That means course 1 is dependent on the course 2. Simultaneously, course 2 is dependent on the course 1. In those kind of cases, none of the course can be completed. And this is how basically we're gonna solve this problem by using the BFS and the Kahn's algorithm. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named findOrder, which has integer n and two-dimensional vector named prerequisites. Now we are taking a vector in, initialized with 0, and vector order, and we are taking a vector adjacency list and a queue. Now, for each of the element into the prerequisites array, we have to increment the in degree counter and insert the iterator 0 into the index of iterator of 1. Now, for each of the element, if any of the element has the in degree of I equal to 0, we have to insert it into the queue. Now here, we have to run the BFS, and while the queue is not empty, we have to insert the front element of the queue into the current and remove it from the queue. Now insert it, the front element, into the order array. Now for each of the children in the adjacency list of current, we have to decrement the in degree of the children, and if in degree of children is 0, we have to push the children into the queue for the next iteration of the BFS. After that, if the size of the order is equal to n, that means we have completed all of the courses or we have processed all of the node, we have to return the order. Otherwise, we have to simply return an empty vector. That means we did not find any of the valid sequence. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.